I charged it. Okay. So we left off at the continuous ones yesterday.
Where is my
Actually, get out your books.
Oh, can I go to my locker and get it?
Yes.
Well, I did not think I'd be using it right now.
You're in math.
We're gonna look at number 26, but it's a graph, and I'm not gonna copy the graph over. So,
Oh my goodness.
Can I go get my Precalculus?
yes. Didn't you walk in and say you had the wrong
Yes,
book?
and then I went to my locker to exchange books, and then I just came
And you left it. That's funny. Good job. 10 out of 10.
10 out of 10 would recommend.
Page are we on? Definitely on page 2000. I mean, not 2200. Oh my god. I mean, 200. I don't think there's a 2000.
It smells so bad in the hallway.
It does.
It's Elijah's locker.
Elijah's locker because he has food in there. All his food containers. It's all his food It's all Elijah's food containers.
It's
His
Elijah's.
locker. It's disgusting.
I think he brought tuna salad one day, and
Yeah,
I think he
and
left
it's all
he left the Tupperware in his locker.
That
I think he might have some like Chinese food Tupperware in there too. Like,
Oh yeah.
Really gross.
Yeah, it smells.
It was
like,
really bad yesterday. Like I don't know what about yesterday, but it was really
like
bad.
liver and real bad like yesterday.
That's disgusting.
Yeah, it was not cute.
No,
Does that still
not
do
cute at
locker
all.
checks?
Might
They
have
should.
to.
They should.
That's lovely.
How many of you fit in there?
No, let me
What
tell
page
you,
is this
I have
on?
not Christian.
95.
I have not seen Christian as happy as when I gave him that first Dunkin' Donuts.
What is that picture that you posted? I don't have a mouth.
What?
Literally look at
What do you
it.
mean?
What are you
Just
talking
being
about?
Dramatic.
What class are you guys in?
Leadership. Wait, I want to
It's
see.
fine.
it.
I've always
this one
me. You
either.
always post really bad pictures.
I want to
of
see
me.
these.
I wanna see it.
You should put it on the projector.
That's not gonna work.
It's really funny.
I don't
Oh, that's
see
No,
it.
it works.
Yeah, no.
Okay, I'll just show you.
She literally opened Facebook. She was like, I have to go talk to
I thought y'all were gonna come tell me about the smell in the hallway that everybody else just
Oh,
came
it
in
does
and told
smell
me
kinda
about.
bad in the hallway,
I
but-
think it smells bad in the hallway. Anyway, it's not
Yeah,
bad.
it's Elijah's locker.
Okay.
Anyways,
On that note, number 26. Okay, it says to state whether the labeled points are a local minimum, local maximum, or neither, and then identify the intervals on which it's decreasing and increasing. So that is where it changes direction. So the point 1, 2, min, max, or neither.
man,
Min. Okay. 3, 3,
Neither.
neither. 5, 7.
Max.
Max. Okay, so the intervals on which it is decreasing would be what?
1, 2.
Oh.
5,
The interval.
7, 5, 7.
The interval.
What
So
does that mean?
I'm only going to write the interval. So the decreasing ones are where the graph is going down, like in the negative direction. So from negative infinity to negative 1, and we do bracket on that. Union. The other spot where it's decreasing is at 5, 7 going down. So 5 to infinity are the two intervals where it's decreasing.
Wait.
Wait, where's
I think it's just positive one.
Where'd you get?
Yeah,
Yeah,
it is.
Yeah, I don't know. Because I was talking about the negative direction. Yes, I'll give you one in a
Oh.
second. Yes, I just said I will give you one in a second. And where is it increasing?
At 3.
What interval is it increasing on?
Let's go with bracket 3, infinity.
It's got to cover the whole graph. So if it was decreasing from negative infinity to 1 and from 5 to infinity, where would it be increasing?
Negative
5.
infinity to 2.
1 to 5.
What? Oh.
Oh, there's no infinity.
Oh.
This is, I don't like this.
I just,
What?
I don't.
I think we
That's
just
just
like to put
yeah.
infinity at this point.
I think so too, honestly. Seems
Yeah.
like it.
Yeah.
I don't like it.
Anyways, so that's all we're doing with that, but I just wanted to show you that because it comes up more later.
Okay.
I mean, I'm gonna give you one to do, but it'll be like this one. It won't be anything weird, like any like weird stuff in the graph.
Guys, we're tied for first in cookie points with like every other class except stat and the algebra
2.
2. Yeah.
All right, determine whether the function is bounded above, below, or bounded on its
Oh, I
domain.
think I actually understood this part.
So, this is gonna require you to graph.
This is
What?
2.
That's algebra 2
What are we
Algebra
saying?
2.
and
So
college
where do
algebra.
you see algebra 1?
Algebra 1's not up there.
Yeah, it's not up there because it hasn't. It's not.
Oh, I thought you said we were tied with algebra 1. I was like, no, they're not up there.
If I'm making mistakes in algebra 1, there's a problem.
I know. That's what I'm like.
That's
I don't
funny.
get that.
I make mistakes.
But they're also really quiet, so even if I did make a mistake,
They
they're
probably-
certainly not
I feel
going to
like they're
correct
scared.
me.
I feel like they're like scared, yeah.
They'll just look at me and I'm like, oh.
Is it, so those mostly 8th graders?
It's just 2 of them, and they're like the quietest ones of all of them.
That's so sad.
All right, so we want to know if this is bounded above, below, or on its domain. So just like bounded in general. Okay. So thinking about this graph, what would this graph be? Okay, a parabola opening which direction?
Okay, so
Down.
Opens down. So what would that mean about it being bounded?
It's not.
it's bounded at the
Or-
top
It's bounded
Wait, how
above.
do you just know it's a parabola?
because it's squared.
Because it's squared.
Oh. I didn't know
Because I'm
that.
just good like that.
Yeah, I was like.
And then the
did you
negative just makes it go down.
Yeah. So if it was a
If it was positive, it'd
X
go up.
Yeah, I did not know any of
And it also is possible that it's not bounded at all, just FYI, just these for these problems. Not this one, just in general.
Of course there is.
38. Y equals 2 to the negative x.
Oh yeah, because if it's just like lines, I mean not lines, but like.
Now, my guess is you don't know what this graph looks like off the top of your head.
I really
Doesn't
don't.
make
Oh wait, is that
sense.
an exponent?
The exponent is a variable. So,
That's so cute.
I was like, did you just write?
your lovely calculator will graph it for you.
Maybe.
It
We'll
is.
see.
We'll see. So, you're going to put it into y equals. Okay, you're going to have to use the little caret to put in the negative exponent.
Arrow.
Don't question it.
I'm questioning it. Why is it called a carrot?
Make
Because
sure-
it's sad.
Make sure that's a negative x in the top. Make sure you use the negative symbol, not the minus
minus.
symbol.
Got it.
Okay.
I've learned.
Now do we hit-
Zoom 6.
Oh, what is that?
It's not even.
Hey.
It just stopped.
Hey, yo.
Well,
It's not bounded.
so it is an exponential function, which is going to have an asymptote, and so in this case, it has an asymptote at 0. So it's going, but it's so close you just can't see it. But it goes all the way out to infinity. So is this bounded above, below, or not bounded?
It's not bounded.
Hey, you messed up. Wait.
No.
Right?
If it gets to a point where it can't go down any further, it has to be
Bounded
what?
Below.
Bounded below.
Wait, so it's gonna get to a point where it can't go any
Wait.
further? Where's it gonna
It
get?
will not cross 0. It will not cross the
It won't
x-axis.
cross-
You messed
cross
up.
0?
Nothing.
Wait, so how do we know
Bro.
that it's not gonna cross 0?
Some of it is just knowing a little bit about exponential functions.
Yeah.
Yeah, you messed up.
Wait.
But
Jake's went the other way.
Oh wait,
Zoom
I
in.
forgot I had the
You gotta-
negative.
it's negative would be my
Oh,
guess.
If you keep going.
Negative.
Yeah.
You can arrow over it. I mean, you may or may not actually see it, but it does.
Yeah,
It will
mine
never.
stops. Mine
It will
doesn't.
never hit y equals 0.
Yeah.
Why will it never hit y equals 0?
How do I go?
If you plug in anything for x, can any number be raised to a power and equal 0?
No.
So that's why.
Go to zoom and then zoom in, and then click where you want to zoom in.
Go Go to Zoom and then what?
I went to
Go
Starbucks
to
this
Zoom
morning.
Like,
and
click
then
the
What?
button.
I went to
click the
Starbucks
button
this
Zoom,
morning.
and then click number 2.
I told all the girls
And
that were
then
coming to like help
put
lead the thing
over-
this morning.
over
I was
the
like,
other
if y'all
button.
place a Starbucks order on your phone, I will go pick it up for you.
No, I was so
Press what?
tired after last night's game. I was out.
My bad, bro.
Okay, so you're gonna go. It's gonna look like what? Oh, my calculator's frozen.
Ah, that's not good.
I'll show you.
No, mine just stops. Mine doesn't have. It just stops. Mine doesn't have like the line keep going on the.
You probably won't be able to see
Yeah, you
it,
probably just can't see it.
Yeah.
but I promise it does. It will never cross the axis.
And we can put
See,
that
look, if
in
you
our
go-
calculator.
Yes.
See, mine is just a different color.
Now, after next section, you
Zoom.
should know what most of these functions look like without having to graph them in your calculator.
And then
The next
move your
section is the
arrow
12
all
basic
the way
functions,
over
and you
to
have
the
to know all of them
No, yeah, no, mine just.
and what they look like.
Mine just stops.
Okay. Whoa.
Mine just stops.
That's
What in
kinda
the-
cool.
My calculator is like 20 years old, so like.
So with this one, would it be bounded above, below,
No.
or not bounded?
Not bounded.
Not bounded.
Oh,
Why?
okay, and
Because
that's
it's
so
crossing the
crosses
X and Y
the-
axis.
Yeah.
So it should look something, well,
What?
It's like
It's like a S kinda.
it's like
Like
but it goes all the way up to infinity and all the way down, right? So it can't be
Yeah.
bounded.
Oh, I was like, how do you guys just know this? Wait, I gotta put it in. I was trying to.
Well, what I said was after next section, you shouldn't really need to graph any of these because they're the 12 basic functions, so you'll have to know what they look like.
yeah. Paying
There will
calculator-
probably be a quiz.
Her calculator's weird.
of course they're
My
Jake, that's why your
calculator's-
Hers,
calculator don't
it
work.
doesn't. The line doesn't keep going. It just stops.
Wait, is it?
I looked at it and I zoomed
Is this
in.
right?
Dropping a lot
Yeah.
of stuff.
Yeah.
Very weird.
So that means not bounded.
Yeah.
Because it just keeps. It's just the line.
It just-
Correct.
It just be like that.
Guys, I think it's time for a calculator upgrade.
I need a calculator upgrade.
Who wants to bring
Invest-
food?
Well, when we get to like the test or something, if you want to use mine so that you can guarantee you'll actually be able to see it, you can.
You should invest in this one. This is the best thing I've ever bought.
When I get a new one, I'm 100% getting the
I
nice
bought
one.
this
Just bring like
8th
that
grade,
whole
and I
pizza.
still I didn't buy this one. I switched calculators because I didn't like the color with someone. But I bought it in 8th grade, and I've used it ever since.
Yeah.
Especially because it's very expensive.
I kind of wish we would just, instead of telling people to get a scientific calculator in 9th grade, like, and I realize like part of it is Miss Marshall doesn't want them to use all the functions in geometry, and I get that, but it's like, you're gonna need it for the rest. Like, I'm sitting here trying to teach Algebra 2 how to do stuff in their calculator that I feel like they should know, but I have to remember, like, they've never used this calculator before.
Yeah.
Like, most of them are using it for the very first time, like, 3 days ago.
Yeah.
And I'm like, okay.
I used this calculator in 9th grade.
I
She
love
didn't
this
care?
thing,
No, she didn't.
Oh.
She said to get this one.
Okay, well, that's good. Because when I was there, she said you could not have anything more than a scientific calculator.
Oh wow. Yeah, she said it was fine.
But,
But we didn't use any of the stuff on it really, other than sine, cosine, and tangent.
yeah, which is
So I
on
didn't know
most
what to do with
calculators.
it. Any-
Got the
But it's just being familiar with where buttons were. I mean, they were looking at me like when I was like,
Yeah.
you need the negative sign instead of the minus sign. They're like, huh? I'm like, oh boy. Because I just forget, like at the beginning, they'd never use it, so they don't know how to use it. So, which is fine. It's just,
Yeah.
You know,
It is
it's
what it
easy
is.
to remember scientific tangent with the
Sokotoa.
yeah,
I'll never
Sacagawea.
forget. It's not
Yeah.
Sacagawea.
Sacagawea.
He's been saying that since 9th grade.
It's Sacagawea.
that's amazing.
It helps
Kenny's
me
dad
better.
has this very interesting acronym for how to remember Sokotoa. Something about horses. I don't really remember. I honestly don't remember it because it's never what I learned. Like,
Yeah.
but it's funny. I said it one day. I was like, "Yeah, we're doing trig," and then he like rattles off this phrase about horses, and I said, "What?" And he was like, "No, that's how I learned it." And I was like, "What'd they teach you in school? That's not how we learned it." I was like, "We learned Sokotoa." He goes, "What's that?" And I was like, "Oh."
Every trig test we had last year, at the beginning of the paper, I'd write Sokotoa. Like, that's the only way I
Also, my
remember.
favorite shape is the dodecahedron.
That's not a
It's
thing.
a dodecahedron.
Dodecahedron.
He would-
Marshall
he
hates
would
when I
make
say
Miss
that.
Marshall
You can't
so
argue
mad.
with him.
Because you would also
Josh is
say,
set in his ways.
what was it? It's the sign. I forgot what you said. It was like prigadigum or something.
Oh, paradigm.
Paradigm.
It's a paradigm. It's a paradigm.
Okay, we're gonna state if the function is odd, even, or neither.
We're gonna.
You also said formaldehyde a lot.
It's a fun word to say.
g of x equals x cubed.
I'm just saying.
So we need to show algebraically, not just guess or state what we think it is. We need to show algebraically why it is what it is.
Do we have to write words?
So g of negative x is equal to negative x cubed, which is equal to negative x cubed. Because it's negative what we originally started with, that tells us that it is odd.
I'm very confused.
Wait, what?
Yeah, I almost
Was
went.
this not in your notes?
Probably
Maybe it is.
Yeah.
It probably is. I just like probably.
There's
forgot.
just a lot, so I don't know.
Oh, it is in our note. It is.
Where is it?
At the end, I think. Where it's like
The end behavior?
WRT x-axis example
Oh,
x equals
that.
y squared. Going ahead to do it algebraically, numerically, and graphically. Graphs with this symmetry are not functions. And then this one is f of x equals x cubed. With this property, a function is an odd function.
So yeah, so we had odd because we plug in negative x. When it comes out, it's negative f of x. So it's negative the function that we started with. Okay, so you could read, really what I should do is do this to show that it's negative of the function we started with. Okay, meaning it's odd.
Oh, because it's cubed.
Mm-hmm.
Oh,
Now,
So if it was positive,
it's
cubed,
just
then-
x cubed, so that you could say it's got a positive, or it's a positive power. It's got an odd power, so it's odd. But if it was like x cubed minus x, you can't just assume that. Now, if it was like x to the fourth, okay, that's raised to an even power, it's going to be even. But when you start adding other stuff to it, that may not be the case. That's why we have to check it. 50. G of x equals 3 over 1 plus x squared. So for it, well, we're going to see what it is, but just to go back through. So we already talked about odd. If something's even, okay, when we plug in negative x for f of x, it should come out as the whole function being positive. Okay, if it's neither, then it's gonna like end up with one thing being positive, one thing being negative. So anyways. So we're gonna plug in negative x, so g of negative x equals 3 over 1 plus negative x in parentheses squared. Okay, if I square negative, what happens?
It's positive.
So 3 over 1 plus x squared. That's what we originally started with, meaning it's what? Even. What was that?
That's how I clear my throat. Because if I don't do it like that, it won't work.
Can you try it?
All right, 52. F of x equals x cubed plus 0.04 x squared plus 3.
What if we did?
You coughing like.
Ew.
Ew. No, iPad kids do
I've
cough
had
like
kids
that.
do cough like.
All right, so plugging in negative x across the board. Negative x cubed plus 0.04 times negative x squared plus 3.
I don't know.
Yes, we
You just need to, so a negative being cubed is what?
Still
It's negative.
Still a negative, so it's still negative x cubed plus 0.04. Negative being squared is
Positive.
positive. And then plus 3. So,
It's either.
is this the same as this?
No.
No. Are they both, did they both switch signs? No.
Oh,
So the whole thing didn't become the opposite sign is really what it should say. Is the whole thing didn't become opposite, so it is neither.
Okay, it is.
All right, and then one more of those. H of x equals 1 over x.
Oh, gods.
See, I think this is like probably one of the easiest things in this section, but it
Yes.
always is the thing that throws people off. So plug in negative x We have 1 over negative x.
Oh, dang it, I have to go to another.
So that means that the whole thing becomes negative. Okay. So, what's that?
Odd.
Odd.
Odd duckling. You did it. You did it. You did it. Hooray.
Dora?
I know, Jake, you're the tallest person in the room. You
And
can
you
sit
sit
anywhere in the class and you'd
So
still
can
be able to
you.
see the board.
What?
But why do you sit up front all the time?
Because it's nice.
He's his own man.
All right. The next one's use a method of your choice to find all horizontal and vertical asymptotes of the function. So, need our clowns.
Bobo Bosco Botno?
So we're gonna find vertical
Bottom,
asymptotes and we're gonna find horizontal asymptotes. I'm gonna show you how they have to be written. If you don't write them this way, it is wrong.
Oh.
Okay?
Okay.
So, 56. X minus 1 over x. Okay, we're gonna do vertical first, and then we'll do horizontal. So, the vertical asymptotes occur when the denominator is equal to 0. If the denominator does not equal 0, okay, then there's not a vertical asymptote. Okay, so if it's not something with a denominator, not gonna have a vertical asymptote. So, where does the denominator equal 0?
Why?
Sorry, I'm trying to.
What?
Why? I don't know.
Where does the denominator equal 0? What value does x have to be for the
0.
denominator to be 0? Yes, 0. So, vertical asymptote. These are lines. Asymptotes are lines. So you have to write it as x equals 0. If you don't write x equals and you just write VA for vertical asymptote and put 0, I mark it wrong.
Because how do you? is
'Cause
it
it's
x
a
equals
line.
0? Is it y equals 0?
Exactly. Some people just do this. They don't even write vertical asymptote and they just go 0 and then they'll get to the horizontal asymptote. They'll be like 3. That's not what it is, but. And I'm like,
How do you know which is what?
huh?
Like it's just numbers.
So you have to label them. Okay? Get in the habit of that now. Label them all the time. So horizontal asymptotes. We need our clown. Okay? So Bobo is bigger on bottom. It's equal to 0. Okay? Botno, bigger on top. No, there's not. Okay? There's no asymptote. Okay? So you would need to actually write that there's not one if there's not. Okay? And then Botno, Bosco. Both the same. It's the coefficient that's in front of it.
Isn't Bosco before Bosco?
Yes.
Yes, but I'm just saying that.
Does it
order.
really matter though?
No. As long as you know them all, it's fine. So, horizontal asymptote, okay, this one is going to be a y equals. So, all we care about is the highest powered variable.
Okay.
Okay? So, if there was, like, if the top was x squared plus x minus 1, we only care about the x squared. Okay? We only care about the highest powered one. In this case, there's only an x on the top and there's only an x on the bottom. So, ignore everything else. Okay? So, I have x over x. In terms of powers, what are those?
X.
Is the top bigger, bottom bigger, or are they the same?
Same.
They're the same. So if both the same, it's the coefficient that's in front of them, okay, directly in front of the x.
So one.
So it's just 1. Okay, so this one is y equals 1.
Oh. That's like.
How fun.
Did you make up this or no?
Actually, I had never heard that. Mr. Cash just made us memorize them. And I don't even remember how we did it because once I worked at Bethel High School with another teacher, and one day we were sitting in class and he's like, we're doing asymptotes, and I was like, oh, great. I was like, I'm not very good at these. And then he puts this thing up on the board and I was like, that's how you do that. And I was like, I can never teach it in any other way now. So
I like this.
it's a beneficial thing to know. All right, 58. Q of x equals 1.5
That's a new one.
raised to the x. Okay, now, when we looked at the graph of number, whatever it was, 38 or something, 38,
Yes, 30.
okay, we said that was what kind of function?
An exponential.
Exponential. What happened when you had that graph?
Yes.
It never crossed what?
Zero.
Zero.
Never cross 0, so I only have a horizontal asymptote at y equals 0. Okay, exponentials do not cross. If it was like +1 or something outside, okay, then it's whatever the same direction as the sign goes. But there's none like that in here, so you don't have to worry about that.
There's no vertical.
Nope, it's not a fraction, so there's no vertical. So horizontal asymptote at y equals 0. Okay, exponentials are pretty much always going to be at y equals 0 unless it has like a +1 on the end or something like that. And at that point, I would graph it and just see what it doesn't cross if you don't know what's happening to it. 60, p of x equals 4 over x squared plus 1.
And now we would also have a vertical asymptote.
So I need to set the denominator equal to 0 and solve. So x squared plus 1 equals 0. So x squared equals -1. So x equals the square root or plus or minus the square root of -1, which is what?
1.
I means there's no value for x, no real value for x that I can plug in that's going to make the denominator 0. So there's no vertical asymptote. So vertical asymptote, there is not one. Okay. I'm writing it on this one that there's none because I don't want you to look back and be like, there's a fraction, I just forgot to write it. Like there actually wasn't one. Okay.
Actually was non-existent.
Horizontal asymptote. Okay. I'm looking at the highest powered variable. Is there a variable on top?
Yes. I mean, no.
What?
No. There's a variable on the bottom though, so it is bigger on bottom.
Figure on
So it's y equals 0.
So it's y equals 0.
Nice.
I was like, I'm okay. So that was just a mistake on my part.
I'm going to modify number 62 just to make it a little bit different so we see something else because otherwise 62 is basically just like the problem we just did. Sometimes, well, here, hold on. I'm going to write the problem as it is and then I'm going to modify it and we'll do it again. H of x equals 2x minus 4 over x squared minus 4. Okay, you have two options with the bottom for finding your vertical asymptote. You can either factor that difference of squares, or you can just set it equal to 0, and just when you take the square root, you're going to get two answers. So I'm just going to do it that way because it's easier. So x squared minus 4 equals 0. So x squared equals 4, meaning that x is equal to plus or minus 2. So your vertical asymptote, you have one at x is equal to 2, and the other one is at x is equal to -2.
Okay, so you can have more than one.
Yes, and these you do need to write separate. Okay. A lot of times I let you combine this stuff like this. Like if we had just been solving, let's just say we were solving that problem, I let you typically just write it that way, even though my college professors would yell at me if I did that, but oh well. When you're doing the asymptotes, you need to write them separate. Two separate lines. Okay. Now, horizontal asymptote. What situation am I dealing with here? Bigger on bottom, so y equals 0.
Wait, so how did you have to learn it? Because this makes it so much easier.
Like actually mathematically. I don't even remember. It was so confusing. I could not figure it out.
Well, why? Thank goodness.
Like he may have explained it somehow like that, but he didn't give us any way to remember it.
Oh, so.
And it's probably like it's one of those things that he had probably never seen before. Like when I teach logarithms and exponentials, I teach an L and an E for how to do it. He didn't teach us that way either. But like when I was prepping my lesson to teach when I was at Bethel, I came in and I taught it that way, and the kids were like, "Wow, this is so much easier than the way we've always been taught it." And the teacher that I was working with was like, I've never seen that before. That's the coolest thing ever. I'm going to start using that. So it's kind of like everybody just builds off of each other. So if it's not something you've seen, like Ethan came in the other day and taught me a different way to factor, and I was like, it's probably easier, but for me it's harder because I wasn't taught that way.
Could you show us?
I could, but I would have to go back and look at how to do it again because it was like 3 weeks ago now that he
was
showed
it
it to me.
something different than like the
It's called the
art
slide method.
Slide.
Yeah. It's less steps.
Mhm.
So
I'm okay with steps though. 'Cause, like,
I like to see.
sometimes the steps are
I like
necessary.
my problem to be right. So.
well, I mean, it is. There's still steps, but it's just like I don't know. It's easier the way you write. It looks more like when you have something where there's not a number in front of your x squared term. It's how you set it up, and then you just do a division step basically. All right. So modifying this problem, we're gonna do x squared minus 4 over 2x minus 4. So I just flipped the denominator and the numerator. So now my vertical asymptote, I set it as 2x minus 4 equals 0. 2x equals 4. So x equals 2. So vertical asymptote at x equals 2. For the horizontal asymptote, what situation am I dealing with now?
There's none.
Bigger on top? No, there's not. So
There's no horizontal.
gonna write none.
Okay, so if the bigger's on the bottom, then
Bigger
it would
on
be
bottom is
0.
Bobo, so it's 0.
That's the last O.
So horizontal asymptote is really easy.
Now, I'm going to do another one here really quick, just the horizontal part of it. If you had, I'm just going to do this. If you had 3x squared over 2x squared, okay, they're both the same, so it's the coefficients that's in front of them, okay? So the horizontal asymptote for this would be y equals 3/2. Okay.
Okay, so you use the coefficient for both the top and the bottom.
Yeah. If you had something like 4x squared minus 2x plus 1, and on the bottom you had 3x squared, okay? I don't care about anything over here. I only care about my highest powered term. Okay, so what would it be in this case? 4 over 3. Okay, so just because I've seen this as an issue before, I wanted to point it out.
Like add in the other coefficients.
They'll like look at like the other x's sometimes or something like that, and it's like, okay, no, that's not what you're looking at. The other one, sometimes you may see something like 3 minus x over x plus 2. What would this one be? -1. Okay, so you have to look at the sign that goes with it when they're not like directly lined up on top of each other. They are the same though, so it is -1.
You're gonna get it wrong.
I was gonna get it wrong.
All right, any questions about any of those?
Actually, no.
Actually, no.
Okay, good. I'm glad.
I say actually because I thought I was gonna have a lot of fun.
Okay, so I'm going to warn you, there's going to be a lot of problems with this section.
Makes sense.
But part of it is because I want to make sure you understand it. Part of it is it's a really long section. So you have to think this is really like 2 days worth of homework in a sense. But you have a little bit of time now, and then I'm giving you all of class tomorrow, and it will be due Friday. Okay, so
Don't we leave at? We leave after school tomorrow.
we leave at 4:10. So we're thinking about having everybody meet in here, and we'll watch the Greenbrier game together.
Ooh,
Online, what I'm
yay.
thinking. So, okay, let's see. Trying to find all my.
That's just kind of fun.
That's a lie.
I know. I kind of like it. It's the end of it.
You know what song is stuck in my head?
What
Like
song?
so stuck in my
The
head.
Jewish one.
No.
Okay, good. I hate that song. I'm okay with Carol of the Bells,
I love Carol
and I like Alone.
I like the new song we're gonna do.
But I do not like.
I like.
I kind of
Jesus
miss
Love
Hallelujah,
Stay
guys.
I miss
or
Hallelujah because we actually finally got the part and then we stopped singing it. Like,
Yeah.
what is this?
Are
What
we
is this
actually gonna
nonsense?
like even do it
We
now?
need to do it. I am